Hello everyone, welcome to the other video for the ABB jogging. Right, in this video I'm going to do the real demo with the robot with two movements. One is the reorient with the world coordinate, and the second one is linear-tool movement. Because these two movements are more advanced and also very useful in some special situation. Alright, so before I start these two demos, I want to point out a couple things. First one, so over here, as you can see, when we click over here, ABB logo, we choose the jogging, right? So that's the first step to set up the robot jogging. And with that screen, one of them is called tool. So obviously you have to choose the tool frame associated with your tooling, right? And on the previous video demo, because I use the default without any tooling attached on the robot, so that's why I choose the tool 0. So that's the default. In the lab, you will see here on this video here, this is a 3D printed welding gun simulation. Alright, so with that we have to choose appropriate the tool setup on this part. Alright, so that's first thing I want to point out. Alright, the second one, you can see here on the if you look at on the welding gun, it has a green dot. Actually that's the laser, so we use a laser pointer to simulate the welding process. Right, so you can see the lighting on here, right? So that simulate. And also the other thing I want to point out is that we talk about TCP, tool center point. Right, with the welding gun, the tool center point is some distance away from the nozzle. Right, obviously that'll be the center from the nozzle, and then that's not very close to the nozzle. It should be either 8 millimeter or 10 millimeter, depends on the welding process requirement. Alright, in our lab, when I set up this welding gun, I use you see here over here, we have a little bit part, aluminum part. That's the dip on this one. All the height on this part is 1 inch. So that's what I use to set up. So you can see from the tip of the nozzle to the laser point to here, the very tip of this reference point, the distance is the 1 inch. So that's where the TCP is. All right. So, and how do you turn on the laser pointer in the lab? All right. So over here, there's a key. Now I'm talking about this part now. All right. So on the teach pendant, there are 4 program keys, right? So there's very easy to identify them. So you have one stroke, 2 of them, 3 of them, 4 of them. Yeah, 1, 2, 3, 4. I already programmed the key number 1 to turn on and turn off the laser. So if you press this key once, it will turn on. It's a toggle key, right? If you press again, it will turn off the laser, right? So that's very useful when you jog this robot in the lab. So you want to use laser as the guidance, right? To look at where you're going, right? So that's a couple things I want point out. So now let's go into the jogging. All right, so with jogging, if you remember with the Fanuc robot, we have the 12 keys on the teach pendant. Maybe I should show you on that. All right, so if you look at before, right, so this is the teach pendant for the Fanuc robot, right? So there are 12 keys on that. They are separate, right? The upper 6, if it's in the world or tool, they move the TCP in linear fashion. The lower 6 will rotate the TCP, right? Instead of moving in linear fashion, but rotate the orientation, yaw, pitch, roll, right? So that's what we learned with the Fanuc robot. But with the the ABB teach pendant, you can see here we only have one joystick, right? So with joystick, you can only have 3 independent movement, right? Either vertical or horizontal or rotate, right? 3 independent movement. But how can you map this? So especially when we are transitioning from Fanuc robot into ABB, how do we use what we learned from the Fanuc robot 12 keys map into these 3 independent movement? So that's something I want to recap. All right. So that's what I put this slide 4 on here. So when you are setting up the jogging, right? So one thing I already mentioned, that the tool, right? The other 2 factors to decide how the robot will move is in ABB robot is the motion mode. So if you click on the motion mode, that will bring up another window or another screen that you to choose among these 4 choices, right? 1, 2, 3, 4 to 6, linear or reorient. And the other factor is the coordinate system, right? So that depends. If you choose the axis 1, 2, 3 or 4 to 6, that means you choose the joint. If we speak in the Fanuc term, right? So with that choice, you don't have any ability to choose the coordinate system, because they are just setting up 6 servo motors to different angles, right? There's no XYZ involved in that. But once you choose the linear or reorient, you will be able to choose among the 4 different options with the coordinate system. So I want to make that clear, right? So the first one is the joint down here. So you don't have the coordinate. But once you choose among these 2, you will have the choice to select either you're doing the world or base coordinate system. Based on this installation, they are the same. Or you can we can call that world, right? Or you choose tool, right? Work object actually equivalent to the if you speak of the Fanuc term, is the user frame. All right. I hope maybe I can use different video to talk about that. That's a different topic. All right. So it's just a little bit of recap. All right. So that means like you choose joint. So that means each choice over here, you map into 3 different independent movement on the joystick, right? So that's how you map up with joint. And then when you choose when you want to jog in world, right? So you choose linear. That will be the upper 6 in the linear movement, right? And then the lower 6 will be the orientation of yard pitch roll. So that's what I'm going to demo on this one, right? So that's how we map into there. So there are 12 of them, right? The upper 6 will be, let me clear the screen, all right? I want to make clear on it. So if you choose this one and then you choose world or base, you will have the upper 6 keys corresponding to the Fanuc robot. All right. But if you choose this, and then that's a bad illustration. All right. So let me rewrite. So this will be your first choice. That corresponds this with 3 operations on here. And then if you choose the second one, if you choose the reorientate, that also map into 3 different movement with world, right? So that will map into the 12 keys. All right. So I hope that make it clear, make it easy for you to understand. All right. And then you will see it over here is a little bit awkward, right? You have to go into this jogging menu in the ABB, then you choose click different part and to make different choice to switch around. I guess ABB realized that, so that's why on the teach pendant on here, if you pay attention on here, there are 2 hard buttons on here, right? Maybe later on I can zoom in, you can see very clearly. So these two hard buttons allow you to choose those, like jog between this, toggle between this, and also this, right? You just need to practice a little bit to get familiar with. So these two hard buttons will allow you to change the setting what I mentioned on this part without going to this screen, right? For example, you are doing some program editing or maybe setting up different things. You don't have to go back to ABB to go into Jogging to set up those. That's going to be too many clicks, right? So ABB gave you these two hard buttons, right? So there are also other buttons to do the other options, all right? So you can practice in the lab, all right? And then speaking of the hard buttons, I just want to finish all this part. At the lower part, there are 4 keys on here. They are the keys to test the program, all right? So in the following video and labs, you're gonna touch up and program robot. So how do you test? So those are the keys, right? So you can see this is a play button, that's start. And this is a stop button, you stop the program running. Also, you can step forward or step backward, right? It's very, very easy to understand, also in the FNUC term, right? So that's what we learned on here, all right? So let's do the demo. It's very easy to branch out to talk about those too many things, all right? So let's look at the demo. The first one, again, all right, the first one, let me make it clear. So the first one, I demonstrate this. Right now, I'm choosing Reorient and also World, all right? So that's the rotation. So you will see the TCP remains stationary on the green dot on here, and the tooling, the welding gun, will rotate around, right? You can see on here. Let me play. So I start to move the joystick, right? So you can see that's rotate around X because I'm corresponding to the world X rotate, right? So you can see the other direction, right? And then if I flip horizontal, and then I still change to the X rotate. Before, all right, sorry. Before was, you can see this is a good angle to look at that, right? The welding gun itself is a complicated tooling, right? So it has, this is the default, right? If I can use that. So this is the default point of the robot TCP. But right now, we want to move the default into here, right? So because that's where the wire stick out from the nozzle, right, to do the welding. And you can see not only we have offset on this part, we have also offset on here and also this angle on here. This is a truly complicated tooling, right? So not only the location change from there to here, and then the angle change, all of them, right? All the XYZ change. So I already set up the tooling before right now I'm doing the Reorient&World. So before I'm the welding gun is rotate on this way and also rotate this way. So both of them correspond to the X rotation, right? So that's what I do on that. All right. So let's continue. So if I keep doing, this is a Y rotation now, right? Horizontal is Y rotation. You can see there that corresponds to Y rotation. So then right now I'm twisting the joystick. So then the TCP will do will rotate this, right? Horizontal rotations on that. All right. So maybe I should play again that you should see everything on here, right? So this is, no matter what I do, no matter what I rotate, either X or Y or Z, you can see here the TCP stays here. So that's the key point I want you to realize. All right. So because you already teach after you teach the TCP, robot knows, okay, that's my two center point. I don't want to move away from there. So I just rotate because I'm choosing the reorient and world. I just rotate around X, Y, Z. Right. So that's the demo I'm doing on here. Right. So over here you can see that's the Z rotation, right? So let me put back here. We can play again. All right, you can see this is X rotation, right? So the other direction, X rotation, it doesn't move away. Okay? I did a little bit of Y, then I continue on the X. So now I'm going to do the Y horizontal, right? Horizontal move the joystick, but the Y rotation on there. Right, Y corresponds to one direction. Now I'm twisting to the Z rotation. Okay, so this is what you see with this setup. All right. Of course, you can also choose the coordinate system instead of world. You can also choose tool. I didn't do the demo because. You know, the problem with the rotate around tool is that you don't really know what's the angle with the joint number 6, right? With that rotate around, your X and Y is unpredictable, right? Unless you ABB have another choice called the align to align the tool with the world, right? So that but I don't think that's very useful. Instead, if you rotate around world, because you know XYZ direction, so that make more sense on that, right? So that's why I didn't do the reorientate. All right. So second demo is that speaking of tool, right? So like I mentioned, if you rotate around the 2X and Y, it's unpredictable because the J6. But if you do the linear, right? So like I'm doing over here, if I choose linear and the 2, right? So that's gonna move the X and Y, and more importantly, Z direction, the Z or Z, right? Because again, because the welding gun, it has some angle on here. Right, you will see some of the movement. I'd like you to see the demo first. Right, right now later on I'm going to choose this linear as the motion mode and tool as the coordinate system. Right, let's see here. So if you see here, I think I can zoom in later. That you to see over here. You can see I choose tool. That's tool. A linear, sorry, that's a linear, and then I choose the coordinate, and that's the tool over here, right? So that's the setup I'm checking out here. So you can see here again, TCP is here, right? And then if I twist this, that's Z or Z direction. That's line up with that, right? Remember I mentioned that the stick, right? So if you try to grab some part away from the machine, that's very useful, right? Okay, all right. Thank you for watching. That's the end.